When do linear relationships arise? Well, suppose that several input variables have an effect on an outcome. If each variable's individual effect is proportional to that variable's level, and the combined effects add, then we say that the outcome variable is a linear function of the input variables. The food nutrient example had just that property. The amount of nutrient consumed was a summed effect of proportional effects of the food amounts. Food amount A2 is scaled by a proportionality constant VI2 to yield the amount of nutrient due to the consumption of food 2. The overall effects add. Many different outcome variables can have linear dependence on the same set of input variables. Use the notation X for the inputs and Y's for the outcomes, and that would give this sort of relationship between the X's and the Y's. Each of the Y's are a linear function of the X's. Here, the A11 all the way through ANM are known coefficients, and these formulas express the outcomes Y as linear functions of the inputs x1, x2, up to xm. What's the key property of a linear relationship? Let's focus on one of the linear relationships and just relabel it. I've gotten rid of some of the subscripts since we're only looking at one. The coefficients A1, A2, up through AM are fixed values, and the right-hand expression is a function of the vector x. Let's call that function L. So L of x is A1 x1 plus A2 x2 plus AM xm. Remember, the a's are fixed values and the x is the variable. Now, consider any two vectors, x and z, and any two scalars, alpha and beta. Define scalar vector multiplication just like we have in MATLAB. You can multiply a vector times a scalar, and the scalar ends up just scaling each one of the components. Then let's look at what happens when L is applied to the sum of alpha scaling x plus beta scaling z. Remember what L does to any vector. It takes A1 times the first component plus A2 times the second component plus AM times the last component. Let's write that out. Here is A1 times the first component of the vector alpha x plus beta z plus A2 times the second component of the vector alpha x plus beta z, and so on. What is the first component of alpha x plus beta z? Well, it's the first component of alpha x, which is just alpha x1, plus the first component of beta z, which is just, by the same reasoning, beta z1. So make those substitutions. In each case, the component of the sum of the scaled vectors becomes the sum of the scaled components. Now group the alpha terms together and the beta terms together, and then notice that this is just L acting on x, and this is L acting on z, giving. This held for any x and z and any alpha and beta, and that's the defining property of a linear function. A function is linear if when it acts on the scaled sum of two vectors, it always results in the scaled sum of the function acting individually on the vectors. Let's talk about some linear functions that you can work out in more detail in the quiz. Suppose I have a construction crew, $105 an hour for the master carpenter, $82 an hour for the plumber, and $37 an hour for the apprentice. And there's a task of replacing a toilet, and the input variables are the time for each task. X1 hours to remove the toilet, that involves the plumber and the apprentice. X2 hours to remove the rotten wood, that's just the apprentice. X3 hours to reframe, that's the master carpenter and the apprentice. X4 hours to purchase and deliver the toilet, send the apprentice for that. And X5 hours to install the new toilet, that's the plumber and the apprentice. With the hourly wages fixed, I claim the total cost of the job is a linear function of the individual task times. In the quiz, you'll write out what that linear function is. Let's switch the roles and imagine the time for each task is fixed. A quarter of an hour to remove the toilet, 3/4 of an hour to remove the rotten wood, 1¼ hours to reframe, 3/4 of an hour to purchase and deliver the toilet, and finally a half an hour to install the toilet. And the hourly wages are the input variables. Z1 for the master carpenter, Z2 for the plumber, and Z3 for the apprentice. With the individual task times fixed, the total cost is a linear function of the hourly wages. In the quiz, you'll write that expression out as well. Finally, let's make everything a variable. X1 through X3 for the hourly wages, and X4 through X8 for the time for each task. Then express the total cost as a function of these 8 variables. The various products enter the total cost. For instance, X1 times X6. Notice the master carpenter's wage is X1, and the master carpenter is involved in the task of reframing. Consequently, the total cost is not a linear function of the joint set of these 8 variables. You'll write that out in the quiz as well.